talk to you, albeit very briefly, about the work that I had done during the course of my dissertation titled Small Molecules, Big Impact, Investigating the Hydrides in the Interstellar Medium. If you take a look at the background image, you see that the space between stars or the interstellar medium is highly complex and inhomogeneous. So most of this is not empty. Now, the main component of this interstellar medium is gas. But why are we interested in studying gas? If you take a look at the first panel, you see an illustration of the gas life cycle of the interstellar medium, wherein which you start with very diffuse and dilute material, which condense to form dense clouds, and eventually stars and stellar systems, much like our solar system. Now, over time, as the central star evolves, it begins to release energy and mass back into the interstellar medium, recycling material and continuing this process. So from this diagram, we see that the stages prior to star formation are important, not only because they are the sites for star formation, but also because they're important chemical laboratories. But how do we do this? Well, we take a look at the unique spectral signatures of key hydrides. Hydrides are molecules or molecular ions in which one or more hydrogen atoms are covalently bonded to a heavier species, as you can see illustrated on the sides. So here we have the spectrum collected using different ground-based and space-borne telescopes and arrays, and you see the spectrum of a few key hydrides that trace atomic material. Everything from argonium on the top, which is the first noble gas-bearing molecule discovered in space, all the way down to atomic hydrogen. So if you notice the spectra, each of them look pretty similar in terms of where their peaks, where their dips coincide, but their shapes are very, very different. Now this tells us not only about the chemical enrichment of the gas, but also about the physical conditions. Moving on to the third panel, this just illustrates one such example of the use of hydrides. So the ratio between the two stable isotopes of carbon is essential because it traces the nuclear history of that region. Here we have the 12C/13C ratio shown as a function of the distance from the galactic center. It seems to increase, which reflects the amount of nuclear activity present in the inner galaxy. Now this diagram is fraught with a lot of variation. But identifying that CH is a unique tracer which is unbiased, we performed very timely observations using the SOFIA telescope and detected 13CH for the very first time in the